Hello everyone, and welcome to the first video for the section 3.5 notes, where we're going to begin our discussion here of rational functions. We're actually going to begin and end the discussion of rational functions here in section 3.5, but without further ado, let's get into just a definition here of actually what a rational function is. And I've mentioned it sort of briefly before, but a rational function is simply, like it sounds, how rational numbers are fractions. A rational function is basically a fraction as well, but this fraction, it has to have a polynomial on top and a polynomial on bottom. As long as you have that situation, and of course q of x, it should not be the zero polynomial that just goes 0 for every x value. For example, like q of x equals 0, that would be called the zero function. You cannot have the zero function on bottom, but anything else goes. As long as they're both polynomials, then when you divide them, you will get a rational function. And so, of course, it comes up, this idea of rational functions, whenever we're talking about doing the polynomial division, because here we're basically dividing two polynomials by each other. Now, what we're going to get into first here is just a little bit of notation. We've seen before talking about end behavior, the end behavior of polynomials. Now we're going to talk about basically end behavior as well as something else. I'm just going to call this in general infinite behavior, because here with the rational functions, we're not only interested in the behavior at the ends, as you have these kind of things like whenever x is going to infinity or when x is going to negative infinity. It's possible to have some kind of infinite behavior in between, and that behavior is happening around these kinds of things over here that are called asymptotes. An asymptote can either be a vertical asymptote, it can be a horizontal asymptote like we have over here, and this horizontal asymptote, here I will mention that this is a vertical one, and this is a horizontal asymptote. Horizontal asymptote, they will have some significance whenever we're talking about the end behavior, as well as just kind of any infinite behavior, because what you see happening around a vertical asymptote is not that x is going to infinity, but this time y is going to infinity somewhere besides off to the ends. If you remember, with a polynomial, you have this kind of end behavior. For example, this is a positive coefficient, kind of a polynomial where the leading coefficient has a positive value, and it's also with an even degree. Then we had the end behavior that whenever x is going to negative infinity, y is going to infinity. When x is going to infinity, y is going to infinity. Now we're going to have a different situation for the rational functions, where whenever x is going to positive infinity or negative infinity, we might have that y is actually just approaching some value besides infinity. And then it might be the case that whenever x is approaching just some number, not infinity, but just some number, we may have the case that y is approaching infinity or maybe negative infinity. And so those are why we're calling them infinite behavior rather than end behavior when we're talking about rational functions. Now, something that we can tell basically just from this graph over here, which this is a graph of y equals x minus 1 over x minus 3, which is this function that's given there. We want to tell just by the graph of this what the infinite behavior is. And so, for example, whenever x is approaching positive infinity, f of x, or else the y value, is approaching what? Look, whenever x is approaching positive infinity, that's whenever we are over here on the right side just continuing to go more and more to the right. It's going this way. And you see the y values, they're not getting bigger. Actually, as we come to the right over here, the y values keep getting smaller and smaller and smaller. But they are approaching this horizontal line here, which is the line y equals 1. So if we just continued this line, coming this way, this is the line y equals 1. And the x values, as they increase and increase just all the way out towards infinity this way, the y value actually always gets closer to 1. And it makes sense whenever you look at what the function is here that we're doing. Since we're taking the number x and subtracting 1 to get the numerator, and we're taking that same number x and subtracting 3 to get the denominator, always, the numerator will be larger, of course, than the denominator. Numerator is larger than the denominator, but do you notice that the values, especially whenever you're looking at the proportion of these values in relation to each other, since that's what this is a fraction, and so fractions are kind of like ratios, the numerator, it's always larger than the denominator, it's always bigger by 2, but they get very close to each other. These numbers on top and bottom, they will get very close to each other as we increase this x value. They get close to each other, and of course the number 1 is whenever they're actually equal to each other. But no matter what number you plug in for x, they will never be equal to each other. They only will get very, very close. And so for example, if you plugged in 1000 or something, f of 1000, we will have 1000 minus 1 on top over 1000 minus 3. So it'd be 999 divided by 997. So the top is bigger, but only slightly bigger. And this number is barely bigger than 1. And you could think if you plug in 1 million or 1 billion, they will even get closer. This number will get closer and closer to 1. So that's how these asymptotes are working, these horizontal ones. And we'll talk about later how we can find the horizontal asymptote for a given rational function, but this value of 1, that is what f of x approaches as x approaches infinity. And you will notice the same thing happens on the other side, and you can think about that it's basically the same reason why. As we're plugging in these negative numbers, if you subtract 3, then you actually end up with a more negative number than what you'll have on top, because on top you only subtract 1. So as we're coming to the left, as x is approaching negative infinity, the number on bottom is always slightly larger. And so by larger, I mean, in absolute value. For example, if we plug in negative 1000 on top, let me put here f of negative 1000. So as we're going towards the left, the top will go negative 1001 and the bottom will go negative 1003. And so this number is actually slightly smaller than 1. But as the number gets bigger again, as we're going left, like if we plug in negative 1 million or something like that, then this number is getting very close to 1, but it's always slightly less. Either way though, we say that as x approaches negative infinity, the f of x, or else the y values, also approaches 1. It's just approaching 1 from the underside. And then we have a little bit of notation here that we did not encounter before. Having this superscript that's a plus sign, which that one means from the right. So here we have as x approaches 3, and then we pronounce this little symbol from the right. We're wondering what's happening to the y values. So approaching from the right simply means we come to the right side of 3, and we're getting closer and closer to 3, where the x values are getting closer to 3. And you notice what's happening to the y values as the x values get closer and closer to 3 on the right side. The y values just keep increasing, so it's going towards infinity. And then similarly, this little minus, we would pronounce out loud from the left. So this is as x approaches 3 from the left this time. So we need to be on the left side of 3, coming closer and closer to 3 from the left. And so as we get closer to 3, you see what the y values are doing. The y values keep going down, 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 all the way to negative infinity that time. And so this is just a little rundown on infinite behavior for these ones. We will be interested in identifying these asymptotes, figure out how you can take the equation for the function and find the vertical asymptote, find the horizontal asymptote if there is one, and eventually we will be interested in actually graphing these rational functions. And so that does it for this video, but thank you guys for watching, and I'll catch you in the next one.